We now have a little bit of a front end where we can look at the foods that are in our back end. And we previously created, we look in our Rails application, we added the ability in the index for get foods to also send it the parameter, the name of the food. And if that parameter is present, we do a partial match to find those foods. If you remember back to Akko's on Thursday, where we added question mark, oops, not here,
Something
here,
like,
question mark name equals Akko's, right? This finds all the foods that has ACOS in their name, right? We did that by saying, we'll take whatever parameter that is name, and if that's present, we'll make our list of foods this query. Otherwise, we'll make it all of the foods. So if we don't give it a name here to search for, then this name will be nil, this will be false, and we'll get all of the foods. If we provide a name equals A, in this case, then you can look in Rails server and say, oh look, there's a parameter called name that has A. Right? That is this parameter right here. So that name in this case is present. So this variable will have a value. This will be true. And our list of foods will be all of the foods where the name column is case insensitive, like the pattern %, whatever's inside the name variable %. This is a partial match. Eyes glazed over, or do we get it? Yeah, cool. So, right, this is like a little search. Let's see if we can implement that search on the front end now. Right. So let's put into here, let's put it up here. Let's put another p tag in here, search, and then let's put an input. Type is text. So here's our search, right? And we want to be able to type ACO and just see our tacos, right? This is what we want this eventually to be able to, as we type these letters, we want this list to adjust and search. So if we remember that to have an input here, we need to track the value of this input, right? So we're going to add a second state here, and let's call it name. And we'll start it out as blank. And our input, the value of this input is going to be this.state.name. So whatever's in that name variable state is what's going to show up on our input. Right, if this has Akko's, then our box has Akko's in it. Let's also put a placeholder in here. Something like this. So it says search. Okay. So if the value of this input is the state name, we need an on change to change it. Yes, that would be Kento. He always hums, and he always hums Harry Potter.
I love it.
Right? So now we have an on change to handle when we type in the search box. So this means we need a method called handle search change. It takes an event. Inside of here, what we can say, not an event, Gavin, an event. Let's get the name from the event target value. And let's change the state name is name. Right? This is back to week 3-4 React. So now we can type here And if we look in our React Dev Tools, we'll see that the name here is tracking what I type. Right? Our input field and our state for this name are tracking each other. Right? They're tracking each other. As I change what's in state, I'm changing what's in the input field. As I change what's in the input field, I'm changing state. But what happens after I type A, C, O? I want the search to happen, right? Every time I type a letter, that has to come here in the callback for state, right? We stumbled onto this, I think, in React, where the set state is asynchronous, right? Just like our fetch is asynchronous. That we have to have the action for after we've changed state to be in this callback. If we did it after this code down here, state may not be updated yet, right? Because set state happens asynchronously. So what we want to have happen in here is, after changing state, the name we are searching for, let's make an API call to search for food, right? After we type in an X, we want to search for all the foods that have an X in their title.
So this is pretty much this, I would say, not standard, but mostly what you're going to be using when you set it, like resetting state, the logic of whatever else, whatever is relevant to that set state needs to happen within there.
If you have something that has to happen after the state is changed, it has to be in the callback of set state.
Okay, and so what would just be, if it were out of there, would there be a use case to kind of set something after, like, to be?
Not usually. Okay. If it's dependent upon state, no.
Okay, yeah.
Now, we have the full name here, so we could have done it outside, but we'd have to use this name variable, not this.state.name, because this name is the full name. But I want to show you all that this is probably a better style.
Cool.
So what we want to do here is we want to do a search for a food. Well, that code looks just like this, right? Almost entirely like this. Except, right, we have to tack on to the end of this food. I'm going to get rid of the JSON. That was just for Garrett. Right? We don't need the .json for us. He needs it for him. Right? What we want is name equals to whatever's in our state. Right? If we have Akos in our input box, we want this to be name equals Akos. So this has to be string this.state.name. But we also now have to change these to backticks because we're doing string interpolation. So inside of changing the state, we're saying, hey, every time you change the state, please go fetch localhost 3000 foods, but add in the param name equal to whatever is in the state name, and then do the same thing. Get the response, turn it into JSON, console log the response, and set the state. So now, hopefully, as I type an X, I get just Gravlox. If I type in an A, C, O, G, I have a little search box that dynamically searches my API for foods. If I type an F, I get just waffles. Type an E, I get waffles and steak. Because as I'm changing state, the set state happens, I do the fetch. If I happen to also have my Rails terminal open, let's type in a param name equals A, C, param is what? Name AC. If it changes to an X, there's my request from name equals X. So every time now that I'm typing, I'm doing another API request to fetch something from the API. Right? That API that we've created, that we used in Postman, will be the same API we use from our React front end, just from JavaScript code.
Did we keep the state of name empty?
No. We started name, we started name being empty.
Yeah.
We said the inputs value is whatever's in the state name. When that changes, call handle search change. Handle search change says get the value from that input box and change the state name to the value of that name. This may help you if I call this input box value. Like this. Right? We get the input box value from the input and we replace the state with that. I know there was a lecture that Mark did about input boxes and two-way binding and on-change events, right? Keeping track of that. Yeah.
One list? Yeah.
One list,
Yeah.
and probably a couple of others, right? We're just using state, the name attribute of our state, this.state.name, to keep track of what's in this box. Hello, right? Every time I type a letter, that state is changing down here, right? Because every time I change that input, I'm changing the name and state to whatever's in the input box. But every time I do that, I'm also now asking the API to do this search. Right now, every time I change a letter in that state, I'm saying go fetch foods, but also let the name be whatever's inside of that this.state.name.
And is the input box value? Oh, I see it. Okay. I see what you're doing. Okay.
The input box value is there.
Yeah.
Right? So that's using that little extra feature that we added to our standard scaffold. We added this code here to what Rails generated for us because we wanted to be able to search for a food by its name. Right. The very first thing we did in our React application is we just hooked up listing the foods. Now we added an input box that lets us search those foods. This is the process you're going to go through, creating your API to be able to produce some data and then updating your user interface in order to consume that data. Right? Bless you and bless you. Right?
So we need to make the get a data from API, for example, like YouTube. Do I need to get a like API from YouTube and make a?
No, you're not going to be using YouTube for what you're doing. You're going to upload the videos yourself.
Oh, okay.
Yeah. Either you're going to add the YouTube as a URL, or you're going to handle the videos yourself.
Right, it's gonna be URL.
Right. So then you're not going to be doing anything with YouTube's API at all.
Okay.
You're just going to be using the YouTube URL to put that into the.
So I need to make URL and title.
The first thing. So what are y'all working on right now for your capstones? HTML, right?
Yeah.
HTML and CSS. Once you have that like 80% done, the very next thing you need to do is bring to me your ERD diagram for me to approve it. 1000% I need to have those by Friday.
Okay.
If you're not at ERD by Friday, you are behind schedule. Because then you have your boxes of all of the nouns, the people, places, and things in your application and how they relate to each other. Because once you have your ERD, you can Rails scaffold those nouns.
Do I need to draw it or?
However you like. However you think you can best explain to me what are all the tables and columns in your database. Usually the easiest way to do that is with an entity relationship diagram like we showed you. Movies, actors, ratings, right? And a list. This is why the HTML is so important, because you should be able to see everything your application needs somewhere in your HTML, right? Anything in your HTML that's dynamic, that comes from the user, is likely to be in a table, right? So Garrett's is a list of yoga classes. The name of that yoga class is going to come from the user. Well, that's going to go in the database. So probably he's going to have a entity in his ERD called a yoga class. And one of the things that that attribute is going to have is the name of that class. Right? So forth and so on. So once you have your HTML pretty much good, you should be able to look at it and say, what are all the people, places, and things, mostly things, in your app? What are all of the attributes of those things? A troop has a name, right? Maybe a troop has...
A number.
What's that?
A number.
Yeah, a troop number.
Yeah.
Maybe it has other things. What are all the attributes of a troop, right? Troops are going to have events. What are the attributes of an event? When is the event? Where is the event? What time does it start? What time does it end? Right? So forth and so on, right? A job. What are the attributes of a job? The salary, the requirements, the location, so forth and so on. So that's why having that user interface, you should be able to look at your HTML and identify all the things, and then all of the data that relate to each of those things. You should literally be able to like underline them in your mockups, right? Or in your printouts or in your wireframes. Those become your ERD. Your ERD becomes your resources in your Rails application. That's going to start to generate an API. You're going to use Postman to check that your API has everything you need, right? You're going to be able to create troops and create events and delete events and create videos and create yoga classes and update a pattern. And once you know that from Postman your API works the way you want, then you can come back to your static HTML, turn it into components, change that hard-coded list of things into something dynamic from a hard-coded state. How are you going to know what state to base that off of? Well, you should probably use one of your API results as an example, right? I should be able to take one of these APIs, right, results, and if I were coding this, right, I should be able to come in here and say, oh look, my foods are all of these, right? That API example that you get from Postman is probably your initial hard-coded state. Then you're going to replace that hard-coded state with an API call. Just kind of like we did with all of your API React examples, except you were the one who created the API. So now you are building the API. It's like you're wearing two hats. Some hours you're going to be wearing your Rails hat, your backend hat. Then you're going to take your backend hat off and put your front end hat on and be like, what did that backend person who I just was a minute ago wearing that backend hat create? Oh, it's this API. Let me use it. Oh, I need something else. Let me take my front end hat off, put my backend hat on, make some more APIs. Okay, done that. Take my backend hat off, put my front end hat off, go back into React and start building my JavaScript code to consume, to use that API, right? So some of the things we haven't talked about yet, that maybe we'll talk about this afternoon or tomorrow, depending on what our timing is. All we've done so far is one thing, right? We can only track one food. What about something like a recipe for that food, right? There may be multiple recipes for tacos, right? And each of those recipes might have multiple steps. How do we do one-to-many and many-to-many relationships in an API? So all we've been able to do so far is create, read, update a single food, right? But foods may have many recipes, and recipes may have many steps. Almost all of your APIs are going to be of that style, where there's a relationship. So we have to now see, how do we build a relationship based API on top of what we've already done. Right? For instance, I should maybe be able to click on one of these foods and see all the recipes for it. Click on one of those recipes, see all of the steps for it. Because right now, all that our API can do, if we look at our resources, our routes, is just foods. So we probably also could be helpful if we had recipes and recipe steps. Because your capstones are probably going to have more than just one resource, right? Troops, leaders, events, yoga classes, poses, etc., right? Patterns and steps and counts, right? Videos, images, YouTubes, codes, etc. Yeah, right? Jobs and locations, right? And every company might have multiple job postings, right? Which may have one or more locations. We'll find out, right? So the next thing we need to layer on top of this is one-to-many and many-to-many relationships. And maybe what we'll do at 3 is create a form to create a new food. Right? We have no way in our user interface yet to create a food. It would be nice to have something to let us create a new food and input that says, what is give me a name, a category, calories, a price, a rating, an expiration date, and whether it's gluten-free or not. And then push that into the database and see our user interface update.
And we're supposed to be able to search price and of a taco, and that's how it's supposed to work like that?
Right now, all we've done is being able to search by name.
After we add it though, that's essentially the information that pops up with the search bar?
Right now, it's just searching the letters in the name. Right? I tried to do this to give you an example of like Animal Safari.
Yeah.
Same thing like when you're searching for species.
Okay.
It's a one-to-one mapping. If you follow exactly what I did in the video, I basically gave you the weekend homework.
Yeah.
Here. But
Yeah.
not names, species, not food, animals. Now, if we wanted to be able to also search by price, we'd have to add more code to our Rails portion, right? Because there's nothing in here that does searching by price. We'd have to have another condition. If they gave us a price search, then search by price. We'd have to write that code here first, then use that in the API. All we have so far here is name equals to, because all we've added here is params name. If we wanted price searching, we'd have to write the backend first, then write the front end code that uses that backend to search by price.
When we do this backend first and then modify the front end,
Mm-hmm.
that's why we start to do ERD first.
Mm-hmm. Mm-hmm. But see, what you're actually doing is you're doing the user interface first, which gets you to build the backend, which gets you to build the data, which gets you to build the API, and then link the two together. So you're starting with the front end, that's informing the ERD, and you're building from both sides together.
Like this.
Yes, right? Because you saw that what I had here was I had a hard-coded list of foods. Right? Then I made that based on a hard-coded state. How did I know what shape to make that data? Because I looked at my API that I had built from the little database work that we did. Hey, we need a food that has a name, a category, a calorie, a price. Once I have this shape of the API, then I can come back and fill in this. Right, the very first time I did this, I had this instead. I had name is eggs, name is tacos. Right? How did I know to make it an array of objects with a name? Array of objects with a name. Once I have my API, then I can turn my static HTML into dynamic state, but from hard-coded data. If I really wanted to be adventurous, I could have just copied this API result and shoved it right here into the state before I hooked it up to the API. I know you all did that before, like you went and you copied JSON into the state, or you made a .json file, and then replaced that with a fetch call. Same idea here, except you were the one who created this API. Try this with the animals homework. Right, it's pretty, so yeah, the Safari homework, right, where you're maintaining animals. It's pretty much the same idea. Yeah. And maybe this afternoon when we get back at 3, we'll make a form so we can post and create a food in our database.
Awesome.
And then we'll see how to do multiple objects and relationships in the back end.
Yeah.
Right? That's why if you get your HTML and your ERD, then we can start making the resources and relationships in the back end. Get out Postman, see if our data looks correct, create some troops, create some yoga classes, create some videos, create some patterns, see that our API has the data that we need, hook it up. If you follow the process, actually hooking up the API and getting it to work will happen in like 2 hours on a Wednesday afternoon. If you put in all the hard work before that. Right? Students are always amazed that if you just follow this pattern, they literally see the hard-coded app that's been hard-coded for weeks all of a sudden become an app. But you got to go through all of that work to get there, right? It's the idea that like making that really hard thing simple happens because you did all of the steps you have to do to get there, right? I remember a student made like a travel app that was like, I'm traveling to this city and there are people in this city and I want to see those people when I go there. And he had his whole user interface static and he built the entire API. And then we replaced his static state with a fetch call and it was live to his database. And then he could create new people and everything was working because we flow through this process. That's why we insist on you like getting the HTML done so you can create the ERD. So you can create the Rails app, so you can create the scaffolds, so you can update the JSON that's in the API, so you can go back to your front end and start using it. It's like this, but more complex, right? Just like Kitchen, except we just don't have one model with a bunch of foods and a really simple list item UI. It's more complex than that, but fundamentally it's this, just many times over for what you're going to be doing for your capstones. Cool. This should help you with the Safari homework. And when we come back, we're just going to add a form down here and we'll create a food. Any questions on this? Right? Hooking React front end and our back end together.
Yeah, kind of. So I mean, we're using Ruby. We use Ruby to control the data, essentially.
We're using Ruby to build our backend to manage all the data. Yes.
Okay, and that's where. So so we're supporting our JSON call, given our control, like what is being returned.
We know what APIs we have because we can look at the routes that we created.
I'm just wondering about that Rails routes.
Right. This tells us all of the APIs we have and what actions they go to. We can list foods. We can create foods. We can show a single food. We can change a single food. We can destroy a single food. By using these URLs, /foods list them, post /foods create them, etc. You're going to have a whole long list of these. Right, this is going to go on a full page worth of stuff because you're going to have more than one model in your app. The more models you have, the more routes you have.
So everything gets added in the controller's part of our backend, all that info that we want to.
You're going to have multiple controllers.
Yeah, multiple.
There's going to be a controller per model. So if you were building an app, you're going to have a troops model and an events model and a troops controller and an events controller pretty much everything in your ERD becomes one model and one controller.
Okay.
If I have a widget, I have a widget model and a widget controller. If I have a car, I have a car model and a car controller. If I have a tire, I have a tire model and a tire controller.
So there'll be possibly 3 or 4 for me, 9 for Mira, like just
As many as you
many
need,
as you need. Okay.
right? And all of the controllers and actions and URLs that go with it, and then you use those in your front end, right? If we look at, let's go find one list API.Heroku app. I think this is what it was. Or was it just one list? I'm trying to remember what the name of the one list was. Oh, I think I got it right. Yeah. Do you see a pattern? Get items, get foods, post items, post foods, get items ID, get foods ID, put items ID, put foods ID, delete items ID, delete foods ID. Holy crap. It's almost like Jason did a Rails resource for one list. This is a nice HTML fancy version of this list. Because Jason, when he made one list, did Rails new API database Postgres. Rails generates scaffold item and listed all the parameters. And he got back these routes. Even so much where, ID text complete true. Wow, doesn't that seem a lot like this? ID name category gluten-free true. That result from one list looks a lot like our API for foods, right? So if your final project was a make a to-do list, it's just like what Jason did, right? He figured out what the ERD was. It's a one model, it's a one element ERD, it's items. What does it have? It has a text and a completes flag, scaffold, API, work in Postman, generate this, make a front end for it. Your capstones are more complex than this, but the process is still the same. So you've done all this before, creating front ends that consume APIs. None of this is different, except for the fact that typically you've been given what the API is. Now you are building both sides of that. Makes it more complex, yes. Just think of like, put my backend hat on for a while and worry about the backend. Take my backend off. Oh, cool. Now I'm a front end programmer. Let me go look what the other backend programmer did, which was you, and start using it. Right? There have been projects where one student does all of the back end and a different student does all of the front end. And when we had IronYard version 1, that's exactly how some students did their projects, because we had back end only students and front end only students. And sometimes they teamed together and one person just wrote the entire back end and another student wrote the entire front end. And what they shared was that JSON API. They agreed on what this was going to look like. The back-end programmer built a back-end that generated this. The front-end programmer wrote the JavaScript code that processed this and turned it into front-end. You all are doing both because you're full-stack students. When students did that, when we had a back-end student and a front-end student, their work was not half as small. It was actually larger because we made them do more work. Right? Because you had to show all your skills as a backend developer.
Yeah, it's kind of crazy that we only did backend in like what, 2 weeks essentially. Is that how
we are in our third week of the backend.
Third week.
You did so it's 3, 3, and 3. 3 fundamentals, 3 front end, 3 back end, 2 weeks for your capstone, and a week for graduation.
Yeah.
It's kind of a 3, 3, 3, 3. 3 weeks of fundamentals, 3 weeks of front end frameworks, 3 weeks of full stack, 3 weeks of capstone and graduation.
Yeah.
/ career support finishing, preparing you for post-graduation.
Yeah.
3.3, 303. Cool.